G'day. In this video I'm going to take a look at the Hercus software which I use to create the programs from which I make parts. We'll just look at 4 of the CAN cycles that the software has available. They're fairly important. So I've designed up this part. It's not a real part. It's just something to let us use these 4 CAN cycles of deep drilling, stock removal, screw cutting and grooving, and they're quite important, so I thought we'd have a look at them. Got to remember this software is 25 years old, so it may not be up with what's available these days. And that's the first line of the program. It says that we're using absolute measurements, we're using metric measurements, and G95 is units per revolution rather than, say, inches per minute or whatever. The next line we do a tool change. We're actually calling up the first tool, and if you've got a turret you'll get a tool change take place, or you'll get a dialog box telling you to put tool number 1 in place if you're using a quick change tool post, say. G50, this is where you set the distances from home to the part for this particular tool. Now we've set the spindle speed and the direction of rotation, and this feed that holds until you put another command in to change it to a different feed. GOO is a rapid move, and that brings the tool up to the beginning of the deep drilling cycle. So that line has Z10 away from the Z origin of the part. G83 is the number for the deep drill cycle, and in one line it has the parameters for that cycle. So X is 0, Z is the depth of the hole, R is the retract position, which means if from each peck it comes back out to that retract position. Q is the depth of each peck, and you can just change that if you're not pecking enough, and F is the feed that you're using for that cycle. G52 sends the tool home out of the way, and in the next line we also turn off the spindle, because these machines were originally made for educational institutions and they wanted to be as safe as possible. I tend not to do this in my programs. I leave the spindle running. Now we're calling up tool 2, and M6 is the tool change again, so the turret would move, or you get a dialog box telling you to change tools. Tool 2 I think is a right hand turning tool, which should be appearing any moment. There's the G50 line, which calls up the 0 position presets for this particular tool, and this happens with each tool change. It calls that up automatically, and you have to set it to suit that tool for the job. Next line again is calling the spindle speed back up and the clockwise rotation, because it stopped it before the tool change. I don't do that when I write a program. I delete those lines. So we rapid the tool to position, and then I think we do a move, which is at the set feed rate, and that faces the stock off, and then we rapid, which is as fast as the machine will possibly move. Then we start the G66 stock removal cycle. Now it's one line, but all those positions that it's going to follow, they follow that first line, and the P190 is telling the CAN cycle that that's the line that it starts at. Q270 is the last line of code that it takes notice of. U is the amount that it leaves on the diameter, because this is after all a roughing cut. W is the amount that leaves on faces, which I usually make small so we don't chatter. D is the depth of cut, and F is the feed. That's all contained in that one line. So if you want to change the amount left on the diameter, or the amount on the faces, or even the depth of cut. You can change all those within that line, and it can make quite a difference to how viable that can cycle is. G67 is a finish pass which goes after the G66, and you can use a different feed rate. So you can say have a 0.1 feed rate for your can cycle to remove the material, but for the finish pass you can make it 0.05. Now we GOO wrap it again to get the tool out the way, and the next tool change comes up. Now that should be a grooving tool. I won't keep repeating myself with all the M5s and the tool change things. So we've rapid moved to send the tool to the beginning of the threading cycle. G76 is what the cycle is called, and in that line X is the minor diameter, Z is the thread length, K is the depth of thread, D is the depth of the first cut, F is the pitch, and A is the thread angle. Depth of first cut is important because the software then computes all the cuts that follow that first cut. So if you put a very small first cut, you will actually find that you've got a lot of cuts. If you put a large first cut, you'll have fewer cuts. Now we're changing to the grooving tool. G72 is the grooving cycle, X being the minor diameter, Z is the end of the groove because you put in the beginning where it starts, I is the depth of peck, and K is the width of the tool, and F is the feed, because you usually need a different feed for that. I mean it's 1 there, it should be sort of 0.03. So that's very handy when you have to remove that sort of material there. Yeah, I got that wrong. That tool shouldn't be there. It'll sit there for a minute and then it'll move to where it ought to be to go around that chamfer, and that's a move. I don't use grooving cycles for parting off because they tend to want to peck, and I don't peck. If you've got good parting tools, I find that they would just go in at the feed that you specify and give you a lovely surface finish. If you peck, you don't get a good surface finish because you see marks everywhere you start and stop the peck, so it becomes a bit silly. So I just use moves. But for grooving like that demonstrated there for that can cycle, it's really good. So at the end then it will, when you terminate the program, M5 is stop spindle, M2 is the program end, and that's about it. Hope it hasn't been too boring for you. Let me know in the comments how this compares with modern day stuff. Thank you for watching.